We'll start a discussion of patterns with the strategy design pattern. There are 23 design patterns in all. We'll take a look at all of them, and 23 standard design patterns. And the strategy design pattern is the one we're going to start with. And first, I'll begin by illustrating the problem it's designed to alleviate. Say that, for example, you've been charged with the task of creating a set of vehicles in code, and you want to, for example, start with an abstract class. This is Java code, an abstract class called vehicle, which will serve as the base class of your vehicles. Have an empty constructor and a method named go. And when you call the go method, you say that the program will print out, now I'm driving. So this is the base class of your solution, which is your task is to design a set of vehicles. For example, you might be charged with designing a street racer, and you say street racer extends vehicle. You have your own constructor in that case, street racer, and extends vehicle means it inherits the go method as you see there. So when the go method is called of the street racer, you should see now I'm driving. So you can in fact test that out in a main method in Java, and you create a new street racer object this way. And then the street racer object contains the go method, which is inherited from the vehicle class. So you can say streetracer.go. When you do, you see the output, now I'm driving. So far so good. And then you go on to create another vehicle, Formula 1. This is a new file for the Formula 1 file. This is going to be a Formula 1 race car, and it also extends the vehicle class. It has its own constructor like this, an empty constructor like that, as you see. You can then, in addition to creating a street racer object, you can create a Formula 1 object and then say formula1.go. So you've created two different types of vehicles here, street racer and Formula 1, and they've both inherited that go method from the vehicle class. You do this, you see the go methods of each object has displayed the now I'm driving method statement. Now, however, you're asked to create a different type of vehicle, a helicopter. Once again, you extend the vehicle class like this, and you say you create a public empty constructor like that, and so you now have the helicopter class extending vehicle, and you can in a main method in a separate program, you can create a helicopter object, and then you say helicopter.go, and you get 3 times now I'm driving. You see that now I'm driving doesn't really work for helicopters. It should be saying something like now I'm flying. So already the way the solution of this problem is beginning to break down, and somebody now asks you to create a jet vehicle. You say public class extends vehicle. You say have a empty constructor here as well, public constructor as well, and you run that. When you run that, you get now I'm driving as well for the jet. You realize that that's wrong. It's just, you should say now I'm flying, or now I'm flying fast, or so forth. So the problem is you have classes whose functionality doesn't really agree with the base class functionality anymore. The first solution could be that you override the go method in each of the new classes. For example, the helicopter class extends vehicle class and overrides the go method to say now I'm flying. So when you run the test case now, you'll see the helicopter object prints out now I'm flying instead of now I'm driving, because you have overridden the go method. And the problem with that is, this is the problem that the strategy design pattern was designed to address. The problem with that is that you're now maintaining separate code for all your classes over various generations of inheritance. So if you have to override the base class's functionality in many different classes inherited from that base class, you have spread out your solution over many different generations of inherited classes, and that's a problem, because if your base class has volatile code which should be changed for subsequent inheriting classes, you don't want to have to edit all your inheriting classes to override that code all the time. This is the problem the strategy design pattern attends to, which is that you now have a situation where you have volatile code in your base class, and you don't want to have to override that code in all of the multiple generations of classes inheriting from that base class. This is the strategy design pattern. It attends to just this problem, which is you don't want to spread out your programming over many generations of inheritance. That's very hard to maintain. So we'll take a look at how the strategy design pattern fixes this problem next.